event, especially since I've not spoken before and you have no idea what I'm going to do or what you've let yourself in for. So today's session is dedicated SQL pools, a deep dive. So we're going to say dedicated SQL pools. We're not going to say that anymore. We're not going to say Azure Synapse, dedicated SQL pools. We're going to say SQL DW. It's easier. It's much better for me. Otherwise, it gets a bit too confusing. My name's Mark. I'm a PM on the Azure Synapse product group, and I spend most of my time in Azure Synapse in dedicated SQL pools, serverless pools, talking to customers, helping them out with issues. So I call this session a deep dive, or how to look clever and impress people, because I like the geeky stuff, and I think that impresses people, doesn't it? Might not be for everybody. So when I've done this session before, I've actually put up a Slido and then asked people what they want to cover, because this session actually covers a lot more stuff than what we're going to cover today. So we're going to cover command 2. That's an aperitif. That's like a little starter. That lets you know the level of where we're going. Round robin tables, about how the data is actually distributed. Distributed tables, distribution. Why did I write that? So that should be replicated tables. We go way too much into that. There's a bit on dirty reads and partitioning, result set caching, materialized views, and then hopefully I'll throw in something a little random at the end for people to have fun with. And really, no more slides. That's it. We're just in Management Studio. All the links and a load of background information I've put here. Anything other downloads or things I've referenced, they're here. And this presentation is up on all the stuff is up on GitHub. So everything I'm doing, there's no secret source, there's no kind of special stuff I'm doing because, you know, I work for Microsoft. No, this is everything that you can get to, you can do yourself, except I've just had way too much time on my hands. Okay, so, and I'm also going to try and skip. So it's a good job Jared's done his beginning bit, because I'm going to skip a lot of the stuff. I'm just going to say replicated tables and hope that kind of you understood that. Okay, so I put together, like, what is a DW? Right, we've got different databases. We've got master, and we've got, this is my database, TPCH, and it is just a 1 terabyte loaded in TCPH data set. So really, it should be about 8 tables. But I put all this extra other gubbins for testing. But essentially, it is really just nation orders, part supplier, line item, which is a big table, supplier table. Most demos around supplier table because it's a good size. So we've got some DMVs. What version are we running? If I run it against master, you'll see we get this. So is that visible? I know this should be okay. This might be hard to read, but if the output is a bit tricky, I'll do some zooming in. So that just says it's Microsoft SQL Azure. Wait a minute, I thought we were working on a data warehouse. So data warehouse, add that version. Now it is a data warehouse. As you see, that was updated a few days ago. Okay, what size am I running? There we go. That happens to be 2 nodes. I can also do the same thing with this query, but I've got to run against master. This is actually a much nicer one. It's to master, run it. Yeah, there we go. My master database. Just going to switch it back. There we go. How many nodes? So you'll see that some DMVs don't run against master. This is a DW 1000, which we will say has got 2 nodes. But we're actually saying it's got 2 compute nodes and 1 control node. You always get effectively a control node. That's the head node, I call it, because yeah, that's what we call it in Hadoop. But these are the ones doing the work. So, and then we can see the calls, so we can see their names. We can actually see, so the distributions Jared was talking about, you can see them, and I've got 60 of them, and you can actually see that 30 of them are attached to PW node node ID 15, and the rest are attached to 13. So you can actually see where the distributions are attached to, and this changes as I'm scaling up. I've got some DMVs put into queries. These are all in the links table sizes. This shows me all my tables and sizes. I can have a look at how much space is in my tables. Current state, any errors I've got, locks, the sessions, SQL requests, external work, so any poly-based stuff, table distributions, table mappings, we're going to touch on later. But essentially, there's some DMVs that describe the system. Okay. Now, if that's bored you, right, we've got rid of the first level of people. So the first, the people easily bored. They're not interested in any of the code. Okay. So this is something that's really cool. And if you don't think it's cool, this probably isn't the right session for you. This is how I filter out and get the right people in. All right. So if I run a query, and I'm just going to run a really simple query, and all I'm putting out is a short string. And I'm going to use this thing called option label. Now, all this does is it marks it so I can find it later. Really useful when doing testing, right? Really useful all the time. So I'm just going to run that query. And then I'm going to run another query that's very, 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 very long. Same label, just so I can find them. Now, in the DMVs, we used to store only the first 4,000 or 3,999 characters. So that when you looked at the SQL string like this, I can see, so DM exec requests is what queries have been run and what's running. I can see that there is a thing called label, which maps up to here. Fabulous. I've got my command, which is what I've executed. Now I can see what was fully executed here. But if I now look at this, I go, what did I execute? Well, it only goes up to very. It doesn't have the rest. So why is that a problem? Well, when you use Power BI, you do big queries, you're using other systems that generate SQL. That becomes a real nightmare. You can't see what's being executed. You can only see the first 4,000 characters. So you then have to go back to the source system to find out what's executed. Until now, where we've got command 2. So if I now show you, get back to where we were. Sorry, not very good with the mouse. Okay. So I can show you the length of command, it was 52 characters. The length of command here was 3999. I don't know why it's not 4,000. There's obviously some issue. We've added this new thing here called command 2. And in command 2, we've got the full length of the string. Now, if that doesn't make you happy, I don't know what will. It might seem like the smallest thing in the world, but for when you're looking at queries, this is amazing. There is, so I can now create, so I'm going to create a view. Let's see if I've done it before. I'm going to create a view. Oh no, I need to create, don't I? Yep. And then I can then go and see, look, here's my full SQL string. Now, the reason why command wasn't just extended out is because if you've got any monitoring systems you've written yourself or any third-party monitoring systems, and we suddenly just add a whole load more string in data into this, it will break stuff. That's why I had to add command 2. So makes sense. Okay. The reason why this script is sorry. Sorry about that. It's kind of 7 in the evening here. It's almost time for my bedtime. The reason why we're going to need a bigger boat is because, let me run this again. Oh, no, let me run my view. There we go. Is because they're my request IDs. If you look at the other lower level DMVs, the request steps and the SQL requests for either of these, you'll see that I've added them at the end. Oh no, I need the longer one, which is this one. There we go. This is the long query. It's still maxed out. These are still truncated. So it's not ideal. It's better than it was, but it isn't perfect. And that's why in the world of Jaws, we're going to still need a bigger boat. All right. There we go. Now, that's got rid of kind of, the disinterested people. If they're not interested in DM exec requests and command to, right, we're not worried about those people. We've got rid of them. Now, who's left behind? We're the core people. We know what we're doing. Okay. Just going to see how many people have dropped. Okay. So I've got a query here, and we're going to look at round robins, and we're going to look at distributions, and we're going to look at tables. Query here. Oh, master. There we go. This shows you all the tables that I've got, the current distribution, how many rows, and the size on disk. So it's a very standard query. It's very useful to have. And there's something that I noticed, and one of the reasons why I did the presentation is that when I was looking at some of these round robin tables, and maybe some of these might be good examples. You'll see that, wait a minute, yeah, like that one, yeah, round robin nation. You'll see that there is 94% data skew. On a round robin table. And if we believe what Jared has said before, it evenly distributes it. So I thought, well, I mean, that's what I thought. So I went in and then I had a little look. So if we now go into one of my largest round robin tables, I can't type my password. There we go. All right. So the definition of a round robin table is that the data is evenly across all distributions. Now, if you think about it logically, it would just be too inefficient to write single rows to each through the 60 distributions. If you think about it, it wouldn't work. So logically, it's writing blocks of data, and those blocks of data can be different sizes. So if I have a look at a particular table, which is, I think, line item, which is my biggest table. Oh, master. This is the amount of rows on each distribution. And you will see that they are all different amounts, not even. And if you actually look at the difference between the smallest and the largest, it's 99 million and 100 million. The difference is like 44,000. So it's not massive as a percentage, but it is significant. So what's actually happening? So let's go and do some work. You do. No questions? Good. All right. I'm going to drop any tables I've got. I'm going to do it on the right database. Okay. I'm going to create a table effectively in the same shape, a round robin table. So distribution of round robin. The default is CCI. I could have chosen heap, but I'm leaving it as a default. I'm selecting star from supplier, effectively getting the shape. But when I use a 1 = 0, that's just the schema. So I'm getting no data. Now, the reason why I'm doing that is I'll show you later. I'll show you this now. So something that Jared touched on is that although I've created one table, I've actually created 60 tables. It's one table, actually one physical table on each distribution. So if you ever wonder why it seems to be doing a bit more work than you think, that's why. So I'm going to insert some data into my table. And the reason why I'm picking 139 rows is a very specific reason. So if I now, so what I'll do is I'll run a query here that just counts how much data is in my tables, my new table, nothing. See, nothing up my sleeves. Now I'm going to insert 139 rows. That number is specific to this table. What it's done is it hasn't inserted one row across or two or even two and a bit across my distributions. It's actually put everything in one and then one in another. So that's a chunk of data. So 38 rows for this particular table. So it will be different on every single table you work on. So it's not a magic number, it's just magic for this table. Every row I insert, so 138 is just enough to fill a distribution to then move on to the next one. So if I use 139, it spills over. And then what if I insert 139 again? And then it's moved. It hasn't added it on. It's gone, I've got a block of data, I'm going to insert it. I can just hear you all going, ah, this is magic. It's not magic, it's SQL DW. And then, perfect. Right. It wouldn't do this earlier, but occasionally it does this. Now it's gone, wait a minute, I'm not going to install these blank ones. I'm going to just go over the top of an existing one. So now I've doubled it and I've doubled here. So the term that it is equally distributing depends on the amount of data that we are inserting. So if I do a quick truncate and I insert 1,000 rows in, you'll see something that looks a bit like this, which is quite a lot. There we go. And then if you add that up, that would be kind of 1,000 rows. So if I want an even distribution of data, I've got to insert at least 8,280 rows. And then what I get is a nice even distribution. So just be aware of that. So this sort of even distribution across, you have to have a certain number of rows. Otherwise, you're getting data skew, and then you'll get data movement. Now, obviously, the data movement is, bytes. It's not significant. But if you're doing lots of small inserts, potentially you could be creating massive data skew. And then all you need to do is see it as a table, and you will get rid of it all. All you need to do is just recreate a copy of the table, do a table rename, and that skew then goes away. So that, that's really round robin tables. Really useful. Just be careful of that. Okay. Any questions on that? And if not, I'll move on to replicated tables. Is everyone dumbfounded or going off for lunch? Yeah, we know. All right. So what is a replicated table? Lots of people, so Jared explained this really nicely, and I think that we leave a lot of ambiguity in it. So the replicated table has a full copy accessible on each compute node. So it doesn't say it's on each compute node, it's accessible. So some people will tell you it's on the compute node, some people will tell you it's done something, it's cached, it's something. It's not. This demo is very similar to the last one, because replicated tables are round robin tables. I know. I can hear everybody's jaw dropping. Okay, let me show you how I know this. Because I'm not here to tell you, I have to prove it. So I'm going to, if I've got one, I'm going to drop it. Okay, so it doesn't exist. I'm going to create one just as before. And then I'm going to do an insert exactly the same thing I did before when I was doing it for a round robin table. So this is a replicated table. Yeah, sorry, should have highlighted that bit. That's how we know it's replicated. So I've inserted 139 rows in, and what does it look like? Looks very much like a round robin table to me. If I now insert in my magic number again, and again, it's a round robin table to me. And if I do the same thing here, okay, I've got 60 tables here. Now, the reason why this is special and why this is 60, and the reason why I'm kind of drawing your attention is that this will magically change. So a replicator table is a round robin table that when I query it, it will build copies of that table, entire copies of that table that are on certain distributions. So each compute node will have access to an entire copy of that data. So because if I've got one node, I will have the data distributed across my 60 distributions, and then on one of my distributions, distribution 1, I will have an entire copy of the table. If I've got 2 compute nodes, I will have it distributed across my 60 nodes, and I'll have 2 complete copies, one on node 1 and one on node 30, distribution 1 and one on 31. And then if I've got 3, they'll be on 1, 21, 41, until eventually I can have an entire copy. If I've got 60 compute nodes, I would have an entire copy. Now, the reason why it matters is because I'm multiplying how many times I've got that data. So if I've got a 1 gig table or a 1 terabyte table, and it's replicated, and I'm running it on 2 nodes in the way I am, I will eventually have 3 copies of that table. That's 3 terabytes of storage. Okay. So the replicated table is replicated, but it's not replicated straight away. So at the moment, it's a round robin table. And I will also I'll take these and I'll take these and I'll put them in a different window. Now, the reason why I'll do that is to show you later when stuff changes. Actually, I did want the other query. I run this. Every time I run this, I get because I delete the table, I get a different name. So this is just another query that brings back the 60, but it gives me some more information on them. So, you know, where the data is, exactly, right? And then if I run this all, and these give me the size and how much space is used up. So this is before I've done any querying of the table. So I've got essentially 60 in there. I should have 60 in there. I've got 60 in there, and this gives me the size. Okay. Clear that down. Clear that down. Clear that down. There we go. All right. So replicated tables are round robin tables until you query them. Now, the first time you query them, so while I'm not using it, it's in a not ready state. As soon as I query it, it returns the data just like a round robin table. So there is no difference. So if I run this query now, so I'm just going to select 100 rows from it. two things happen. One is it queries it for me. And so I get my 100 rows. It also kicks off this special job called build replicated table cache. As you see, I've run it before. Wait a minute. There we go. So I've got one build replicated table cache. Let's see what the query is. Pop it in there for everyone. It takes so I'm doing this over a subset of the data, but this can take a while. So this is an asynchronous job that kicks off. So my table is returned to me, so my query is done. Then it kicks this off and it actually builds a replicated table in the background. So to show you what it's doing, I'm going to take the request ID from the build replicated table step and show you the request steps. So what was being done in the background. And you'll see, so it might be slightly harder to see. So we've got 6 steps being done. If we scroll across, I don't know whether you'll be able to see, I'll do this one. So we build a table, we create a column store, we effectively create another table, we insert and we move some data, and then we actually build the replicated table on each node, and then we move data into it. So that's all happening there. And if we take this step here, if I show you it, okay, that name matches up with this name here. So it's got the same name, except it doesn't have the distribution on it. It has RC, which is for replicated. So if we run these queries effectively again, what we get are so this one I think stays the same, which is 60. Yep. But then when we are, sorry, I need to paste in the right table name. So I did this wrong once. There we go. We now should have 62. And if we scroll down this list, so effectively 2 have been added in. So we scroll down here and we see there's 1 and there'll be another one somewhere. Not too far, hopefully. This is where people shout at, there it is, people shout at the screen. So if I do that and I scroll across, I can see that that one is on distribution 1 for node 15. But you see, there's effectively 2, isn't there, now? But this is the entire table. This is just a segment of the table, the round robin. This is the replicated one because it has the RC on it. And then when we look at the other one, it will be built on 31. It's almost as if I did this, I told you what I was going to do, told you the result, and then did it, like I knew what was going to happen. Right, now what I did try and do on a previous version of this was show you, if I show you this query again, so my table is replicated, so anybody queries it, it's replicated. And if we have a look at this query, we should see it's in a ready state, so it's replicated. Now if someone updates that replicated table, let's just insert some rows, doesn't really matter how many, any number of rows, it will stop being a replicated table and going back to just being a round robin table. So this, and then when someone queries it again, it will become a replicated table again. So it will go into the replicated table state. Now the reason that's important is because you don't want these tables being updated. So as Jared said, you want these to be updated very infrequently, but read frequently. So, you know, Doesn't matter whether they're dimensions or even, dimensions are ideal, but they could be almost any size table. But the bigger the table, the more data movement, the more time it takes. So you just got to be really careful about that. So, I've seen it where people have got 10 gig replicated tables, even larger, but they're only updated once a month. So it doesn't matter if it takes an hour to build that replicated table, because who cares? Because it's going to be quick all the other time. They do their updates, their ETL, monthly ETL, update the table, bam, it's done. But I've seen it where people put them on normal tables effectively, and they think, oh, well, I'll replicate everything because that's how you make it go faster. And then what happens is those tables are constantly being updated, they're constantly being replicated, and we will only replicate 2 tables at a time. So you can actually get queues of replicated tables, and I've seen that on large systems. So that's something that you just need to be aware of. We're doing this for the right thing. So small tables, perfect. Those small round robin tables, perfect. Tables that are updated infrequently, perfect. And I think that was it on replicated tables. Let's see. We are about halfway through the session, so I'm going to do a bit on partitioning and dirty reads. So I'm sorry if I lost anyone, but this is like a level 400 session, which is why kind of it's probably a step on from Jared's. Sorry.
Necessary pain. Necessary pain.
So good. I don't see many of these type of sessions, so I thought it would be useful to dive into stuff. And all right, so I've been working in data warehouse for about 3 years, and I've seen people explain replicated tables so badly before, but this bit on the RC table, I found it out last week, and I was showing someone in my team, and we'd never seen it before. So just because I'm showing it and going, how clever am I? It's not because I'm clever. I just happened to stumble across it because I was thinking, well, there must be something behind the scenes. There must be something I can see. So if this feels a step on from what you currently do, all it is perseverance and time. There isn't really any. I'm not that clever, really. I will show you. Oh, sorry. All right. I will show you this quickly. And this is me not being clever. This is me actually being clever by reusing other people's work. So a colleague, she's not in my team, but she's another team. She is so much smarter than me. She has written some tooling to help you work out if you should have a replicated table, or if you should have a round robin table, or if there are any problems with the tables in your system. So effectively, it's on GitHub. Here's a URL. You can basically just run a health report on your system. So let me just, and that's where some of these other tables came from. So it says, right, I've got low CCI quality, compress the row groups. There does not have a record to be a CCI. So she's written it to give you kind of all sorts of hints on what you should be doing. Oh, look at it, there's so much stuff in there. It's so good. And so you can just download that and run that, and it just gives you an idea of kind of, could be a good replicated table. So if you're not sure, I'm telling you, I've got some data skew. So I don't even have to know what I'm looking for. All I need to look at are these kind of report comments. So if you are dabbling and you're not sure, this is well worth having a look at. And I didn't write any of this, all our own work, and I am stealing it so I can look clever. All right.
Hey, Mark, you do have a question. Is space use still a good way to get the size of a table in order to check if it's over 2 gigs?
Yeah. There's a DW one as well, but SP space used is the best one. But you will get different results because they count different things. So you just got to be, I think SB space use counts everything. So it counts like the unallocated space and the freed up space, and not everything counts those. So yeah, SB space use, that's what we use. So I was talking to a customer, and the customer wanted to be able to do was getting dirty reads, and read uncommitted is the default state of the system, and they've been using it. They've written the bits of their data warehouse, and they didn't like dirty reads. So there's a few ways around that. One is you do all your work effectively in a staging table, and then you do a table rename afterwards, which is kind of, it's a bit of extra effort, but you don't get any dirty reads. If you had a massive table, you could do partition switching. So you do your work in the kind of the new table, and then you just switch that partition in. Everything works. It's groovy. Later on, we've added in snapshot. I'm going to say, I was going to go snapshot something, but I could just read it in front of me. Read snapshot isolation. So you can actually turn that on, and then you will get rid of your dirty reads. But the customer didn't want to turn that on because they already had an existing system. They didn't have a proper dev system to test what the impact would be. So this is, if you want to get rid of dirty reads, this is the ideal way of doing it. So there's a link to the articles and stuff all behind it. So there were two other ways. So renaming the table was the other way, which is, I can run the scripts. Yeah, they're quite quick. I think, let me just see if I've dropped them. So you just need to shout at me, say, no, master, and then I can remember to change from master. Oh, but let's delete them, make sure there's no data. Let's kind of just embiggen that. There we go. Create a couple of tables. Do you notice how I didn't actually put any with statements? So these will be round robin CCIs. So you don't even need a with statement. But if you have a with statement, you have to have a distribution. You can't have a with without a distribution, but you can skip the heap and CCI. But I'm being really lazy because I'm a lazy human being. Okay, I'm going to insert some data. So this is my live table, and this is my my new table, my new data coming in, and I want to be able to swap it in, and I can just do object rename. So if I just run that, so what's in my staging table? I should have 3 records, and then I've got 1 record in there. Right. And then I run this switcheroo, which is just the rename. Now, the rename is great, but if something is happening on that table, like a CCI rebuild or some stats updates, it will block some stuff. It will block this operation, and then this operation waits. So when they tried doing this, the customer, they also had all sorts of issues with doing this. So while I was thinking about it, and I thought, well, I wonder whether we could do partitioning, but without a partition, because I do remember in my SQL Server days that when you actually create a table, it creates it as there is a default partition. So like there's partition number 1 against every table, that even if you don't create partitions or do anything with them. I wonder whether I could do something like that. So I thought I'd give it a go. So I'm just going to drop those tables again. All right, they don't exist. All right, fine. Okay. I'm just going to create effectively the same sort of test. I'm going to insert the same data. Yeah. So let's have a look. So my end result. This is my staging table. This is what I want to go in there. And then I can just issue a partition switch, but with no partition. And then I go, boom. And it does it. And then effectively my staging table has nothing because I did the truncate. And look, and I've got my data in there. Now, I thought I'm a freaking genius. I bet, and I was going like, this is so good. I mean, this is like, it's going to save loads of effort and time. I'm such a hero. I was showing one of my colleagues, a guy called Ron Orloff, not Ron Orloff, Ron Dunn. Sorry, there are multiple Rons. And I was showing him, and I thought I'd just double check that I wasn't like insane. And this is a good solution. So, and I spoke to Ron, and Ron said, "Yeah, that's an amazing solution. It's so good that I thought of it 2 years ago." And this is when he's already blogged on it. I mean, well, all right, 3 years ago, almost 3 years ago. Yeah, thanks, Ron. So I thought I was really clever, but clearly I was not that clever. Ron's already got there before me. So you see, you shouldn't listen to me. You should listen to Ron Dunn. But since I went to all the effort of writing these scripts in this little demo, I'm going to show it anyway. It's mine. All right. How are we for time? We've got about 20 minutes. So let's do result set caching. Okay. Now, I did call this section when result set caching attacks magicians, but it's not really that catchy. So if I'm going to go to, here we go. So I'm just going to check if result set caching is turned on. Oh, it is. All right, let me turn it off. I'm going to turn off my database. Can't do it. So just be careful. So some things you can alter the database while in the database, and some things you have to switch to master to alter the database. And it's just irritating. Okay. Let me, I'll do. Right. So now it should be turned off. Right. Going to switch to my database. So I'm going to run a query without result set caching on, which is this query here. Okay. Oh, that was super quick. That's not good, is it? Let me change it. Make sure it's the reason why it's quick is this data is hot. And I mean hot as in it's in the cache. It's not hot as in stolen. I'm just going to run this. Oh, I see, it's still quick. Right. It'll work. This is the biggest. This is a huge table, unfortunately. Normally this takes about 12 to 14 seconds to run, but today my data warehouse has been amazingly quick. Okay, so what I've done is I've run that twice. So I wanted to make sure that it was hot. It took a small amount of time, and result set cache is turned off. -1 is off. We have these hexadecimal codes that tell you what's going on. So now I'm going to turn it on. So the reason why this is going to be a little bit irritating is because it should take about 12 seconds. And then with result set caching, it then just happens in a millisecond. Come on. Actually, we've only got 10 minutes, haven't we? All right, result set caching is turned on. I'm going to now run it twice. Yeah, against master. That gets me every time. Okay. Now, the reason I ran it twice is I'll show you in the explain plan, just to show you what it's doing. Effectively, I've got 4 executions. They are in chronological order, so the oldest to the newest. So you'll also see that it's off, it's off, it's disabled, it hasn't hit the cache, it's hit the cache. So the reason why result set caching is so good is that you see that the previous run effectively used some resource. It went from my control node down to my compute nodes, did some work, and then returned the results. Now, the next time I needed it, it went to my compute node, my control node, got the results from the control node, and then threw it back straight away. So it didn't go down to the control nodes. So therefore, I am not using any of my concurrency. So any of the concurrency that you've got on your system with results set caching, you completely avoid it. Now that is super cool, because then I can just scale, I can have huge amounts of queries hitting it, and they're only ever hitting one machine, and it's just returning the data. And that's super cool. But there's a few things you've got to be aware of. Not everything can be cached. If there are certain types of queries can't be cached. If there's a certain type of functions, the non-deterministic, i.e. you run that function twice and you'll get different results, that won't be cached. There isn't a cache per user. Oh, does someone want to shout? No? No? Okay, right. So there isn't a cache per user. But so this is super cool, and for small result set like this, it is amazing. But if I start to go like that, add an extra space or change that to be a capital C, that generates a different plan, a different query hash, effectively, not the same plan, different query hash, which means that it will get cached again. It will check. There'll be nothing in the cache for that nothing in the cache for that hash. So you've just got to be really careful. So if I run this now again, and we go back here, what we should see, if I've done it right, is the very top one, and all I've done was change the letter C. Now that's so you just got to be really careful. So it isn't caching the table, it's caching the results of the query, which is what's called the result set cache. And it's cached on the control node. Yes, control node. Sorry, I get them confused. And then if I ran it again, it would look like this. Okay. This is when it works really well. Small result sets running, and it's super quick. The reason why you just need to be aware of it is because it does more than you think it's doing. So if I show you, I'll show you a hot plan. So I'll show you this one. So this is result set caching off, turned off. This is what the steps of this query look like. It's really simple. What I should have done was popped these in there. Now, this is the one where the cache, it wasn't in the result set cache. And now there's a hell of a lot more stuff going on. We've got these partition moves going on. We've got more steps, we've got more work, because it's actually creating a cache table. It's actually stored in physical storage on an SSD on the compute node. So there is a little bit of an overhead of storing it and writing it. And then if we click the next one, so this is the hot result set cache. We just get one line, it hit the control node, and then it just returned from the result set cache DB. So that's super cool. That's amazing, because that's what we want. Now, when it goes bad, okay, let me have a look. Okay, I ran these earlier, so hopefully I should have the results. Oh, that is disappointing. Results, if I got 3, was that 3 or was that 1? 3. Let me hope I've got the results. Yeah, okay. So I ran this earlier. Now this is this isn't a huge table. It's my supplier table. It's quite big. And so I ran the same test. I ran a hot, so these two are, that's a cold query, that's a hot query, that's result set caching off, result set caching off, turn result set caching on, first query, cache query. So the numbers should bear that. Okay, so effectively no caching, no result set cache, result set cache off, so off, turned on, and then these two. So you'll see it's the same sort of thing. Now, have a look at the times. Now they're in milliseconds, so let's be slightly smart about this and go total elapsed time divided by 1000. This is number. This is seconds. Total. I spelled that wrong, haven't I? Let me just take that out. Oh, I didn't mean to take forever. No. Oh, I see. I was thinking on the wrong table. Oh, good. Okay. Phew. That would have been awful. Okay, let me have a look. Here we go. Right. I thought I'd spelled elapsed right. Yeah, okay. Forget these. That's me. This is the number of seconds. So a cold query took almost 400 seconds. A hot query took 370, but the result set cache, writing into the result set cache, took longer than it would if result set caching was turned off. And if you look here, when it came from just the control node, it was even slower. So huge data sets, large data sets just don't really work. So just remember that when you turn result set caching on, I used to think it was a magic go faster button. You've just got to be really careful with the kind of workload that's going on. So if it's lots of queries, that's perfect. If it is huge bits of ETL, where you're moving, doing big queries, moving huge chunks of data around, you can turn result set caching off for those queries so they can run without it. So that's what you should be doing. Otherwise, you effectively, I mean, that query is what, that's a minute and 17 seconds slower, and it's hitting the result set cache. And you can also overload the control node. So you've just got to be really careful with that. Small queries only. We're almost out of time, so I want to be respectful, not hold people up. Can I show you all the other demos are here? So for materialized views, essentially all I was going to do was show you how to connect to non-master database, run it, use this thing called explain with recommendations, which produces an XML explain plan, but also produces a bit of text, drop it in here. It will also produce some code that is a recommended reg. It will produce, let me have a look. It will, normally I put this into TextPad, but we're running out of time. There's a section in here called, that's it, candidates. Materialized view candidates, and what they will do is they'll give you a sample materialized view for you to run. And there can be more than one, so it'll give you the create materialized view statement, and then you can take that, execute that, and then it saves you having to write the materialized view statement on your own and work out how to do it. I just wanted to leave you with one little thing, if that's all right. And this is a bug, but it's a nice bug. You know, we don't like bugs, but we like nice bugs. So it is a bug, and it's not really to do with data warehouse. But if you're a big fan of SQL Server, you should be aware of live query stats in Management Studio. So you can turn them on. But what you'll see is if you go to the data warehouse, it disappears because it turns it off because they're not supported. Well, if you've turned it on, then switch to master, it does actually work. So I don't know, is that clear enough? Whether I need to do, so that should start going up. We can actually just sit here and watch the numbers go up and just wait for the time to run down of the presentation. But if you look at the DMVs in the background, you'll see constant hits in DM exec requests, getting the row numbers and getting them as they change. So it does take a while because I picked the biggest table, so maybe it probably wasn't the best idea. But this is a nice little, this is unsupported, this is a bug, this shouldn't really be running, but it is a quite nice little bug to actually see some new features coming. Has it moved yet? Someone tell me they saw it move and it wasn't my imagination. There we go.
There we go.
Oh, the anticipation. That's what you need. You end on like really on tension to make sure that everyone's on the edge of their seats. We've lost quite a few, but I think that those that did stay, that it was worthwhile staying, even if you didn't learn every, you know, there's still a bit of a gap. You know, I'm not doing everything. There's so much to know that this is just, you know, a touch on a few things. And that's my time up, isn't it?
Well, thank you very much, Mark. And Jared actually jumped in and helped handle the questions that people were asking. So I don't think we have any more questions here in the chat box. If you guys have questions, come off mute and feel free to ask Mark. All right, well, I'm going to go ahead and stop the recording and thank you very much for